Hey guys, I welcome you all to my new video. This is going to be on aldol condensation. So aldol condensation, firstly I'll just tell you how to carry out the mechanism to this. Later I'll just show you a trick. Basically I usually share tricks and tips as to how you can crack in the questions as quick as possible for your NEET and JEE exams, right? So firstly I'll just show you the mechanistic approach as to how you can use the mechanism and arrive at the product. Later I'm going to share you the tricks, so please wait for that part. Fine. So firstly, aldol condensation, here the reaction is carried out. For example, I'm taking acetone, right? Here firstly I'll take 2 units of acetone, right? Here 2 units of acetone in presence of a diluted base. So the first criteria is to use a diluted base, right? So here we have a diluted base. From this diluted base, what happens is, when this diluted base reacts with acetone, we get something which is nothing but this sort of a product. And what is this called? This is nothing but beta-hydroxy ketone. Why is this called as a beta-hydroxy ketone? So can I tell with respect to this keto as a functional group, this is my alpha carbon, right? This is my beta carbon. So can you see, with respect to this keto functional group, at beta position I have my hydroxyl group, right? And at so we have hydroxyl group. So with respect to this, can I tell, if I am reacting this further upon treatment with a heat, when I provide heat to this, what will happen? Usually whenever you provide heat, water is lost, right? When water is lost, the product obtained is this. Something has happened here. What is this? I'll explain you now. See here. So can you see, at the alpha and beta position we have loss of water. OH is getting removed from here, and from here I have loss of water which is happening. So this is your final product, which is called as 4-methyl pent 3-ene. This is what the product is after using a base at the first step, and in the second step I have just heated up the beta hydroxy ketone to obtain 4-methyl pent 3-ene as my product. Now let us see the mechanism first, how to arrive at this product. So for mechanism, what did I take? I took a acetone. So as you can see here, there is CH2 and I've just flanked one hydrogen. I have written it, right? Why? Because I will be using a base in the first step. Base is going to abstract this hydrogen, right? So after the abstraction, can I tell that there will be a CH2 with a minus charge which will be generated, which is nothing but a carbanion, right? This carbanion is in turn going to act as a nucleophile, right? So with this nucleophile I have another unit of acetone which I used, right? So this nucleophile is going to attack in this nucleophilic center, this nucleophilic carbon, right? This nucleophilic carbon has been attacked, so that this bond will also cleave, because one carbon can have only 4 bonds, right? After the cleavage of this bond, can I tell something like this has been generated? So O minus is here and I have this, right? So after this, what I'm going to do is I'm going to treat this with a water. So can I write water as HOH? Why? Because this minus charge is going to abstract this hydrogen now. That's it. So what are you going to get? A intermediate aldol product, which is nothing but this. So this is my aldol product. Okay, aldol product. Now from this aldol product, if I heat this up, okay, after heating in presence of a base, what is going to happen? Heating causes loss of water. So OH from here and hydrogen from here are lost, right? After the loss, what happens? There will be elimination of water which would have occurred, which leads to this product. As simple as that, right? As simple as that. So this is my aldol condensation ka product. And this was my aldol product. Fine. These are two different things. So this is pretty much about the mechanistic part and stuff. You can have a look at it, the complete scenario as to what I have taught till now. Now I'll get into the the trick part as to how you can solve these questions within a couple of seconds, right? So let us discuss about that now. Okay. So tricks to solve questions based on aldol condensation. Okay. So first things first, if I take for example the same question as the first one, right? So this is my acetone unit, right? This acetone, can I tell this has one alpha carbon here, this as my alpha carbon, another alpha carbon. What am I talking to with respect to what that alpha carbon? This with respect to this keto as a functional group, right? So with respect to keto as the functional group, I have two alpha carbons attached, right? So now I'll tell you, just take any of the alpha carbon, because both the alpha carbons are identical in this case, right? So for now I'll take this alpha carbon and I'll flank one hydrogen from this, because this is nothing but methyl, right? From methyl I just made it as CH2 and H. Now with respect to this same thing, exactly opposite to this hydrogen, I'll place double bond O, right? With respect to this double bond O, can I tell I have this structure, right? So I had taken 2 units of acetone, right? So one unit I have written it above here and the second unit is here, right? So from this what I have to do is I just need to remove this part. Fine. So after cleaving or after removing this part, what will be left? We had flanked one hydrogen, right? So here there is one valency of the carbon which is vacant here, and there is another here. So we just have to join this two using a double bond, right? To be more precise, you can write the structure somewhat like this, right? Exactly same as that. Just for the explanation purpose, I have showed it in a broader perspective. Is it clear? So this is the product of my aldol condensation ka product, right? So this product is after heating. Fine. So when I take dilute NaOH and after heating we get this product, right? So elimination product has been obtained. Now tell me guys, if I take this as my question, I have 2 units of this, right? 2 units of this. So how do you write the product? Can I tell this is my alpha carbon and this is also my alpha carbon, right? From this alpha carbon I can form how many products if 2 units of this are reacting? Let us see this. So firstly I will take this hydrogen, I'll consider this as my hydrogen. So exactly the flanked hydrogen ke opposite mein you need to put in double bond O, right? So here this is what I have taken. So what we have to do right now, we just have to remove oxygen and hydrogen. So when we remove this, what do we get exactly? We get this as a product. Is it right? Yes, this is our product which is obtained. Clear? So this is one such product, and can I tell we'll get one more product? How is that one more product feasible? I'll just show it here. So this was my reactant. Instead of cleaving hydrogen, taking out hydrogen from this part, I will take it from this alpha carbon, right? So I have just flanked this hydrogen up, and with respect to this hydrogen, exactly at the opposite side I have put in one oxygen, right? So here this is my another unit. So what will happen? Removal of this part, right? And join this 2 carbon covalency using double bond O, right? So use this. So is this what the product is? Yes, this is what our product is. Is it clear till here? I hope it is clear. Yes. So next. So now I'll discuss a question which was asked in your NEET 2016. Fine. They had given 2 units of cyclohexanone. 2 units of cyclohexanone, and they reacted this cyclohexanone in presence of a base upon heating. So how do you go about proceeding this? As you all know, this is my keto functional group, right? With respect to this functional group, this is my alpha carbon. This is my alpha carbon. This is also my alpha carbon, right? So here I have alpha carbon. So catch hold of any one alpha carbon. So I have just catch hold of any one alpha carbon. For example, I considered this as my alpha carbon bearing one hydrogen. So I've just flanked that hydrogen. Now after flanking this hydrogen, exactly at the opposite side, I have to put double bond O, right, and place in that cyclohexane ring, correct? So now what you have to do, you just have to remove this part and you have to put a double bond here, right? So this is what the product is. Is this what you all got? Yes, I hope so you have got this. So this was a NEET 2016 question. It was as simple as this, right? So these reactions whichever we have done till now, it is all like a self condensation. So till now we have only discussed about self condensation, or you can also say self aldol condensation, right? These are all aldol condensation. Now can I tell that we can also do crossed aldol? Okay, crossed aldol condensation. How can you go about doing it? For example, I have taken acetaldehyde, right, plus I have taken 1 unit of ketone, right? Here tell me how many alpha hydrogens are available. Here one alpha hydrogen, here another, right? So how many products are feasible? Yes, rightly said, it is 3. Let us see, if I am carrying out an attack here, what will happen? There will be 2 products which will be feasible, right? So firstly draw a ketone, right? So this is my alpha carbon, this is my alpha carbon. With respect to this, you have to flank one hydrogen. Exactly below this, you have to put a double bond O, right? And there is aldehyde, sorry. So this is my aldehyde. So what will be the product for this? Firstly, you have to take down this as my product. As simple as that, right? So this is my first product. What will be the second product of the same? Second product, I will take the same ketone which is going and attacking this part, this alpha carbon, right? This alpha carbon. So what will happen here if I'm taking and attacking this alpha carbon? I have to place an aldehyde here, right? And this hydrogen has been flanked. So just go about removing this part, right? What will you get? You will end up getting eventually this thing, this compound, right? So this is my second product, and these first product and the second product will be my major product. Why is it so? Because as you know that attack on aldehyde is more favorable than ketone. Why is it so? Because aldehydes are sterically less hindered, right? For example, we have taken this and I have taken acetone. So this will be highly reactive. Aldehydes will be highly reactive. And what will be the third product of the same reaction? You have to carry out reaction on aldehyde, right? So here is my alpha hydrogen. Take this and put in the another ketone group. So what will be the answer? Remove this part, as easy as it gets. So remove this up, double bond O and the keto group. So this is my third product which can be obtained, and this will be my minor one. So guys, this is pretty much about your aldol condensation. I hope you have understood completely, right? And I have thought of covering completely, right? I have completed self aldol, crossed aldol also, and this intramolecular aldol also, right? So that I'll be dealing it later. Fine. So the intramolecular aldol is not usually asked in JEE mains or in NEET. Fine. So later I'll catch you up. I hope you have understood this video. Thank you so much for watching, guys. Yes.